Hello guys, I hope you all are safe and fine. So today I would like to share with you all my sixth task assigned to me from Grip, that is the prediction using decision tree algorithm. So let me explain you all what is a decision tree. A decision tree is a diagram or chart that helps one to determine a course of action or show a statistical probability. Now, why a decision tree is used in predicting the model? Decision trees tend to be a method of choice for predictive modeling because they are relatively easy to understand and also are very effective. The basic goal of a decision tree is to split a population of data into smaller segments. Now, I hope all your doubts on decision tree has been clear. Let's move to the objective part of the project. The main objective of my project is to create a decision tree classifier and visualize it graphically. The purpose is, if we need any new data to this classifier, it would be able to predict the right class accordingly. Now, moving on to the main part of our project. First of all, I have imported all the required libraries for this project such as the pandas, numpty, matplotlib.pyplot, cboard, %matplotinline, sklearn.metrics, sklearn.tree, sklearn.model-selection and sklearn.preprocessing. After importing all the required libraries, I have loaded the particular dataset into a local variable and using the head function, I have obtained the first few observations. Based on these observations, our program will be executed further. As a part of feature exploration step, I have used the shape function and found that the particular dataset consists of 150 observations and 5 variables. On using the info function, I have found the data types of each variable, memory usage, and also can conclude that there are no missing values in the particular dataset. Moving further, on using the describe function, I have found the sum of the measures of central tendency for each attribute and hence can conclude that the average sepal length, sepal width, petal length and petal width were 5.82, 3.05, 3.75 and 1.19 respectively. Moving on to the next step of our project, that is the data visualization step, I have plotted a pair plot below and the visualization is here. Then I have plotted a correlation matrix and based on that matrix a heat map also has been plotted below. Now you must be wondering, what is a correlation matrix and heat map? A correlation matrix is a table showing correlation coefficients between variables. Each cell in the table shows a correlation between two variables. A correlation heat map is a heat map that depicts a 2D correlation matrix between two discrete dimensions using colored cells to represent data visually on a monochronic scale. The values of the first dimension appear as the rows of the table, whereas the second as columns. In a heat map, the correlation is interpreted as values closer to 0, which means that there is no linear trend between the two variables. The value more closer to 1 indicates a positive correlation, that is, as one increases, so does the other, and they do have a stronger relationship among themselves. Now we have 150 observations and 4 variables. In order to return the number of missing values in each column, I have used isna.sum function. Later, I have trained, defined and labeled all the attributes present in this model. Then, on using the ilog function, I have selected the first 4 cells of the dataset. Fit_transform function has been used on the training data so that we can scale the training data and also learn the scaling parameters. Here, the model built by us will learn the mean and variance and the features of the training set. These learned parameters are then used to scale our test data. Then, I have split the train and test data and applied decision tree algorithm. The purpose behind why I have split the train and test data is that it helps us to minimize the effects of data discrepancies and better understand the model. Now, the number of observations and variables present in the train and test data has been plotted below. In the training split, there are 120 observations and 4 variables, whereas on the other hand, in the test grid, there are 13 observations and 4 variables. Here you can see that the decision tree classifier has been created. Then, I have plotted a classification report and conclusion matrix below. Now let me explain you what is a classification report. A classification report is used to measure the quality of predictions from a classification algorithm. The report shows the main classification metrics, precision, recall, F1 scored on a per class basis and support of our trained classification model. The metrics are calculated by using true and false positive, true and false negatives. I have used this data to predict the accuracy of its data. The accuracy has been printed below. Now, here you can see a confusion metric. A confusion metric is a metric used to measure the performance of a machine learning algorithm. Each row of the confusion matrix represents the instances of actual class and each column represents the instances of predicted class. It is often used to describe the performance of a classification model on a set of test data for which the true values are known. Coming on to the last step of our project, that is the visualization of trained model. You can see a decision tree plotted below. On visualizing the diagram or the chart, I can explain you that the starting decision is called a node and each branch of the decision tree represents a possible decision, outcome or reaction. At each step or node, we try to form a condition on the features to separate all the labels or classes containing the dataset to the fullest purity. Finally, to conclude this task, for each attribute, 4 pairplots have been plotted with respect to other. Both the train and test data has been splitted in order to minimize the effect of data discrepancies and better understand the model. The prediction was calculated using decision tree algorithm. A decision tree classifier has been created and based on that, the accuracy of the classification report was evaluated as 1. The visually represented decision tree classifier consists of 1 node and 18 branches. I hope you all have enjoyed this video and I would like to thank you all who have spent your valuable time to see my whole project. If possible, I would suggest you to view my previous projects and mention your suggestions, evaluations and feedback over there in the comment section. Links to those have been provided below. Thank you and have a great day.